my name is Ben and welcome. If it's your first time here to this channel is about writing CG or HLSL shaders from scratch within Unity. So in today's video, what we're going to talk about is the basics of a shader. We're going to create a shader from scratch, go through it line by line, and I'm going to try my best to explain what it all means. So if you're completely new to shading, you're completely new to CG or HLSL shader code, this is the video for you. So as you can see here, I already have Unity opened, and it has a lot of files here because this is actually my Udemy course. But let's not worry too much about that because it will serve the purposes of this video. So what I have here set up is a plane, just a simple plane with a standard shader on top of it. And what we're going to do is we're going to create our first shader. Go to this folder, it's empty right now, and I'm going to go right click, create, shader, unlit shader. And the reason why I choose unlit shader because it has the basic structure of what we need. I'm just going to call it my first shader. Cool. Now that's created, I'm going to go ahead and apply it to our material. The first thing I'm going to do is actually do a little bit of renaming. So I've opened it right here, and this is the Unity default unlit shader kind of structured how we want. Right at the very top right here, you see unlit and my first shader. My first shader is the name, and unlit is the folder of where this shader lives. And now I'm going to call it introduction. I'm going to save that off. Here within Unity, I don't have a material yet. That's okay. I have my first material. This magenta look is typically because there's a shader error happening on this. It's because this file is missing. No problem. What we do is we click on shader right here within the inspector. We go to introduction, which I created up here, and we select my first shader. Cool. Now that's done, I'm actually going to go in my first shader and I'm going to remove everything we don't need. Don't worry about me just kind of cutting something that you don't understand quite yet, because in future videos I will be explaining them. But I think for the purposes of this particular video, removing everything that we don't need at this point is probably much more suitable. So I'm just going to go ahead and quickly do that. Cool. Now that that's done, as you can see here at the bottom, I've returned col as a 1 and I've returned col. That just means returning white, and I'll explain that in a moment. Let's move the inspector over here so that you guys can see what this material is doing. As you can see, it's selected here as introduction, my first shader. All right, let's go back to the shader and we'll go to the very top. As I explained before, this is the folder, introduction, and the name of the shader. Here we have what is called properties. Now, properties of a shader could be things like texture, color. They're variables that can affect our material or our shader. And we're going to create one right now. We're going to create one of the most basic properties. I'm just going to create a color, and I'm going to apply it at the end of the shader. So stay tuned to the end of this video to learn how I apply it. So the color property is as follows. I do underscore color as the name, and then I put in the name that I want to show within the material. We'll call it test color so you can see that. Next here is the type, which is a color type, and a color is a vector 4, or it's a property with 4 variables in it, and I'll show you those 4 variables. So what I did is 11111. What it means is this color is defaulting to white. This first channel, or this first variable here, stands for red, green, blue, and alpha. So these 4 digits create this color, as you can see here: red, green, blue, and alpha. It was green before because when I was testing this out earlier, it was already set to green. But if you created a new material, it would actually default to white. All right, so that was properties. So next we have sub shader, and majority of our shader code will go within here. Next we have tags. Tags tell this material different types of rendering properties. So for example, this is opaque. There are properties such as transparent properties, background for skybox. There are other types of tags that are lighting tags. I won't go into those details here in this specific video. Next, we have LOD. LOD stands for Level of Detail 100. Again, this is something I'm not going to go into specifics for this video, but I will do it in future videos, or I will use it in future videos. But what it does is, if you are developing for games that's supporting multiple devices, certain shaders, certain devices can run higher end shader code. For example, let's just say you had an iPhone 10 compared to an iPhone 7, right? The 10 is far more powerful. You would have a higher LOD and more complex shader code within that LOD for the iPhone 10 and something lower for the iPhone 7. Next we have is pass, and passes, shaders can have multiple passes. The most common example would be lighting. Sometimes an object has multiple pixel lights or has multiple directional lights and needs multiple passes to do that type of shading. There are ways to work around it, known as deferred shading, but I'm not going to jump into that right now. For the purposes of learning the basics of a shader, I don't think we need to go into that right now. Okay, cool. Now we're finally here and the meat of the shader, right? Everything in between CG program and CG is, to me, the meat of the shader. And right here, right at the top, we have pragma, vertex, vert, pragma, fragment, frag. What this is we're declaring the vertex shader and the fragment shader, or sometimes known as the pixel shader, here at the top. How the vertex shader works is that it runs on every single vertices. Think of it that way. Runs on every vert. I'm going to put it that. And the pixel, or the fragment shader, runs on every single pixel on screen. That is how you want to think about it when you're running your shader code. Now, so when I say every single vert, it means every single one of these corners within here where my mouse is. These are the vertices of this particular object, this plane. And of course, it doesn't have to be a plane. It could be a building. It could be a character model. But vertex, it runs on each and every one of these. Fragment runs on every single dot on screen. Mind you, these two are running at, let's just say your game is running at 30 FPS. It is going to run that 30 times per second for every single object. We have include unity cg.cg ink, and it's not supposed to be this color. Not sure why I did that. But what this does is it imports this unity cg.cg ink file, and in there's a bunch of shader functions usually used within Unity. I typically leave this here because we often use a lot of those functions. So, and I believe it actually brings the code into your shader. Next, we have struct AppData, and think of this as an object data. It could be an object data or mesh data. AppData to me is not the best name. This really is mesh data. There's data such as vertex, UV, which I deleted earlier, but in a future video, I'll bring it back and explain what that is. But this app data is all the data coming from this mesh. So this mesh is one object. All of this data, all of these dots and vertices are coming through to the vertex shader, and I'll show you how it does that. So right here, we're just kind of declaring object or mesh data, and the first thing it gives us is a vertex, which is the position of each of these vertices. Next, we have struct v2f. It also has a vertices, and what this is it really stands for vert to fragment. How it works is, think of this object as a way for us to pass data from the vertex shader to the fragment shader. Earlier, remember when I said vertex runs on every single vertices and fragment runs on every single pixel? We often use the vertex shader to pass data into the fragment shader because the fragment shader is what's being drawn onto screen. So before I move on, I want to talk quickly about position and float 4 here, as well as SV position. Position is the type of data coming from AppData, and in this case, it is a position because it's a vertex position. This position is in local space or object space. And what it does is it passes that data onto a vertex. And then this one is vert to frag. It passes the data from vertex to the fragment. SV position, what it is, and why is this not called position, I'm not entirely sure, but I do recall some GPUs and some platforms don't support position being down here. But I do believe all of them do support SV_position, so we just leave it that way. Cool. So now we come to float. There are three, or there's more, but I guess mainly there are three different types of variable names that we use to describe, floating points, integers, numerical values. So the first one is here is fixed. The next one is known as half. And the 4 really means there are 4 values here. It could have been 2, and it could be like something like this, right? So the biggest difference between fixed, half, and float is the precision and the range. So fixed has a pretty low precision. It's usually used for color. I'm not exactly sure how much precision, maybe 4 bits or 8. No, I don't think it's 8. But yeah, it's a pretty low precision, and it also has a really low range of, I think, -2 to 2. Half, a little bit more, and float has the most precision. You can think of float as floats in other types of programming languages. But just know this, fixed is low precision, half middle, and float high. All right, cool. So I think I'm going to do a separate video explaining in further detail about fixed, half, and float. I'll also be using it throughout my, as I put out different videos, I'll be using different ones, and I'll be explaining why I'm using a float in this situation or a half in whichever situation. Cool. So let's jump into the Vertex Shader. So the Vertex Shader, which is this block right here, has a type of V2F, and as you can see here, it returns that V2F. Vert here is declared up here, right? And this name, of course, can be renamed, same as the V2F, as well as AppData. Now, the Vertex Shader, what it does is takes in AppData, which is our object data or mesh data. It takes in this data, and within that data, it has one property or one variable known as vertex. So here, right off the bat, we're declaring V2F as O, which means, I guess it means output. It's the Unity's way of saying, oh, this is just the output going to Fragment. This line right here, what it is doing is taking O.vertex, which is the V2F vertex, this one, and assigning it to this Unity object to clip position V.vertex. So it's assigning it to this vertex, wrapped around this function. I'll explain what this function does in just a moment, and then it returns it off to the Fragment shader. So Unity object to clip position. What this is doing is it's multiplying this vertex against something called the MVP matrix. MVP, which stands for Model View Projection Matrix. I'm going to type that out right here. Okay, so it does a matrix multiply against Unity's model, view, and projection matrix. And I'm going to do a separate video on how we can do cool things with this type of matrix, or even do with just the M and the V, or even just with the M. But in a nutshell, what it does is this app data, this vertex data that comes from the object is in local space. What Unity needs to do is move it into model space, which, well, no, that's not quite right. It needs to multiply against the model matrix, which I believe does scaling, rotation, and transform, moving it from local or object space into world space. Then it does view. View is kind of shifting the whole world so that your camera is in the right position, so that you're looking at the object from the right position. And finally, it does projection, because our cameras, at least most of the time, are not orthographic. If they are not orthographic, it actually needs to do some projection math on the object so that it looks right on screen. So you can think of it as this. In a nutshell, what it does is it takes the object's vertex data and puts it in the right position in front of the camera. All right, cool. Let's talk about the fragment shader. So let's break it down. It's a fixed for type, meaning it returns a fixed for, as you can see here. Fixed for is named color is equal to 1, and it just returns it straight up. Frag is the name of the fragment shader that we've declared up there. V2F, this is the data it takes. It takes in the data that we made in the vertex, and it calls it I, which I believe is for input. Next, it has this thing called SV target, and SV target, what it really does is, I believe it just kind of tells it that this fragment shader is outputting a color, a single target. I won't get into the details right now, but there are different types of rendering that uses multiple render targets. That will come at a far much later video. Next, we have half, which is, this is actually the value I made, explaining that earlier. We don't need that here. So here we have fixed for color is equal to 1, and we're returning that color. And because we're returning 1, it's returning white. Now here is where I can start to do a few different types of things. We can change it to fixed for. Remember I said this is the red, green, blue, and alpha. So if I did 1, 0, 0, it would return red. Let's ignore this error. This is a different shader. I'm going to actually fix that up so this doesn't appear in the next video. Yeah, so 1, 0, 0 is red. 1, 1, 0 would be yellow, I believe. And if you put 1 in all of them, it would be white. Now, earlier at the very beginning, we created this test color. What if I wanted to apply it here? Well, if I did this and I just kind of straight up applied it, it would return an error because color is undefined, undeclared. In order for us to be able to use it, we need to be able to declare it here. It doesn't have to be exactly this spot. I think Unity does most of it here, but it could also be declared up here as long as within, I believe it has to be after these pragma declarations. So color is a fixed for color. Now, remember I talked about properties, right? This is a test color. As you can see, if you haven't noticed, we have this test color here. And now that this color is being applied down in our COL, our column, we should be able to change our color and change our shader color here. Cool. I think that will be it really for this particular video, because I think I've gone through line by line what everything means. Don't stress too much about everything I've gone through today. You know, as you do more and more shaders, I'll be going through over the same thing over and over again so that you guys will really understand what is happening here. So if you found this video helpful, I hope that you would subscribe to my channel so that and hit the bell notification as well. So as future videos come out, you will be notified. That's all for me. Bye now.